We're going to be doing market basket analysis with association rules, and for our initial data set we have a really small one, which is 3 transactions. The first one contains bread, butter, and milk, the second one contains bread and butter, and the third one contains milk. So for association rules, our result is always going to be an if-then sentence. So it could be something like if bread, which means that if bread is bought, then butter is bought as well. So such a rule tells us that if a person picks up bread, he will pick up butter as well. Now, for analyzing those rules, we'll look at 3 measures: support, confidence, and lift. And first, let's take a look at support. So support is defined as the probability that bread and butter are bought together. So you can see from our 3 transactions that in 2 transactions that they really are bought together. So the support is essentially 2/3. And confidence, well, confidence is defined as let's put into the denominator the if part of the sentence. So it's the probability of bread which is actually 2/3 again, because the bread is in 2/3 baskets, in 2 out of 3 baskets. So into the numerator goes the probability of bread and butter together. So this probability is actually also 2/3. So confidence is 2/3 divided by 2/3, which is your 1 or 100%. So this essentially tells us, the support tells us, that bread and butter are bought together in 66% of cases. And confidence tells us that whenever bread is bought, butter is bought as well, in 100% of cases. And now let's go to a real life example, which would be something like that. We have 100K transactions, and in those transactions, support is bound to go really down. So it could be somewhere as low as 0.001 or 1/10%. Whereas confidence will remain comparatively high. So it will be somewhere around 50%, let's say. So this means that in 99% of cases, bread and butter are not bought. But in wherever bread is bought, 50% of cases butter is bought as well. So we might have very low support for hardly anything, and very high confidence in those few things that we have support for, or that we're supporting. We have very high confidence in those rules. Okay, now let's go to a really interesting one. This is the lift, and for that we have to look at some slides beneath. So first of all, we have a set of yellow rectangles there, and there are 10 by 10 rectangles, which makes it altogether 100 rectangles. And for the red rectangles over here, we also have a 10 by 10 grid. Now let's say that we're trying to select a kind of a random rectangle on the yellow side. So let's say that we select something on the 5th row, 3rd column. And well, since there are 100 rectangles and everyone has an equal chance of being selected, it's 1/100 is the probability of this rectangle being selected. And now let's do the same thing for the red rectangles, which is basically 2nd row, 4th column is again a probability of 1/100. And now the thing is that next we want to do such a thing, and our result is here, the 2 selected, the probabilities we wrote down. Now what we want to do next is we want to select a specific yellow rectangle, which is the only rectangle we're interested in, because now once we do that, we select a specific red rectangle and we will be interested in the same one. So once again, selecting a yellow one has a probability of 1/100, and selecting this red one has a probability of 1/100 as well. But the fact that they're both together being selected, this probability is actually going to be 1 over 100 times 1 over 100. So the penultimate probability is going to go down from 1% to 0.01%. So once again, if we want a specific one in both cases to be selected, this has together, like we get the yellow selection and the red selection, and they're together the specific one we're interested in, the probability will go way down. And now, let's look at lift. And for lift, we will take the probability of, let's say, bread being in a random market basket, and we will multiply it with the probability of butter being in a random market basket. Both probabilities actually are 2 over 3. So the probability of bread being in a random market basket is 2 baskets out of 3, and the probability of butter as well is 2 out of 3. And into the numerator, we put the probability of bread and butter being in the same basket. And in our case, it really was in 2 out of 3 baskets. So if we define lift, it's going to mean that it's 2 over 3 divided by 2 over 3 times 2 over 3. And these cancel out, and the result is going to be 0.5. So this essentially means that if we took a really random circumstance, which was down there below, we had bread in 66% of baskets and butter in 66% of baskets, and now the really random thing would have told us that they appear together in 2 over 3 times 2 over 3 baskets, but they really appear together in the numerator in 2 over 3 baskets. So they appear together far more often than they should have appeared if it had been a random thing. And this 1.5, so if lift is over 1, this is a good claim for us. And that's how we measure market basket analysis, by those 3 measures.